Welcome to another screencast. This screencast is going to be about cold fronts because we're in the meteorology topic. This is jumping ahead a little bit to a typical picture of a cold front, but let's start from the beginning. Cold air, what it looks like, its shape. This is side profile. This is basically what cold air looks like. The green is supposed to represent land. Yo, 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 representing land, aight? That's the direction which the cold air would be moving. And there's the word cold. Digital wizardry also adds in warm air. So surrounding the cold air is warm. If it's not cold, well, then it must be warm. We always talk about things relatively speaking too. So it's relatively cold air compared to the air next to it, around it, near it. That actual black line is the cold front itself. It's the boundary between the two air masses. My fastest moving air is located up front. Think about a marathon. Your fastest runners would be up front. And then the slowest moving air is all the way in the back. So think again of a marathon. The people that take a really long time to do the marathon, which is still a tremendous accomplishment, I'm not judging anybody, they would be the slowest ones would be in the back, and they would tend to be spread out a lot more than compared to the front of the marathon where the fastest runners are kind of collected. So you will see symbols like this, MT for maritime tropical, CP for continental polar. It indicates the characteristics of the air, and generally in the United States, we are affected mostly by maritime tropical air mass from the Gulf of Mexico and continental polar air masses from Canada, A. This is in your reference table, just giving you an idea of the different types of air masses: continental Arctic, continental polar, continental tropical, maritime tropical, and maritime polar, and then what the front symbols look like. So this is in page 13 of your Earth Science reference table, as if you didn't know that already. So here we have that cold air mass that's moving. It's moving to the right of the screen, and it's hitting into a maritime tropical air mass, which is a warmer air mass. Maritime meaning it's formed over water, Gulf of Mexico, so it has moisture in it. That air gets forced upwards, kind of like a bulldozer hitting it. As it rises, it cools. If it cools to the condensation point, we get clouds. And if it continues to cool, we then can get precipitation. So at fronts, we get precipitation. A cold front, we happen to get heavy precipitation over a short period of time. Look how tall this cloud is, because the slope of the cold front is very, very steep. That warm, moist air gets forced upwards very quickly. Quick condensation, tall, thick clouds, heavy precipitation over a small area. So this whole area would experience the heavy precipitation. So generally, well, not generally, cold fronts result in heavy precipitation over a short period of time. That's one of the characteristics of a cold front. That was a side profile. This is looking at it from overhead. That's what the map symbol would look like. So it would look like, you could see the cold front is right over here. Right, that's from the map symbol. That's on page 13 Earth Science reference table. Everything behind it would be a cold air mass. Everything in front of it would be a warm air mass, comparatively speaking. In this case, we're using specifically continental polar air mass encountering a maritime tropical air mass. Continental polar from Canada, maritime tropical forming over the Gulf of Mexico. That is the area shaded of the precipitation. Notice it's concentrated at the front, and it's heavy precipitation over a short period of time. This is a very typical textbook diagram you'll see about cold fronts. You can see advancing cold air behind the cold front. Right over here is the cold front itself. They kind of put in the map symbols as well. And here you can see the warm air gets forced upwards, giving you clouds and heavy precipitation over a short period of time. This is a map of the United States, in case you didn't know that. And you could see the dividing line in temperatures. You could essentially just draw a line right over here. And here would be my cold front. Everything behind it is cold, and everything in front of the front would be warm in comparison. And then there's something going on over here called a warm front, which we'll talk about later on. And the two connected together give us something called a mid-latitude cyclone. Sounds a lot more complicated than what it is. It's really not that terrible. If I were to look at this, I could see my continental polar air masses would be located here and here, and my maritime tropical air mass originating over the Gulf of Mexico would be over here. If I look at cloud formation, you can see that the clouds form at the fronts because that warm, moist air is forced upwards. We get heavy precipitation, See the heavy, right? This is mixing ice and rain. Heavy precipitation over a short period of time. Very important for you to know that. That's like the most important thing. And you may think you're cool, but you'll never be pink suit, cowboy hat, triple beard, fancy mustache cool. Or maybe you will be. Maybe that's something you aspire to. So it gives you something to aim for. But just a quick little summary. Oftentimes they'll do this, where they'll place letters, and it took me all night to think of this. City A, City B, City C. So City A and B are both in a maritime tropical air mass. They're both warm. City C is in a cold air mass or a continental polar air mass. Right now, B is experiencing heavy precipitation. Over the next couple of hours, what's going to happen is, now the cities don't move because cities don't move, right? And this front is going to move along. And as it moves along, what's going to be the next city to get heavy precipitation? You can see now B no longer has heavy precipitation. Now what happens to temperature at B? City B would start to experience cold temperatures, continental polar air masses. Temperatures would decrease, air pressure would increase. And now City A would start to experience what? Heavy precipitation over a short period of time. And then City A then would actually have cold temperatures. That's the passing of the cold front. So the cold front right here, as the cold front's coming through, heavy precipitation, short period of time. And now you're in a cool air mass, cold air mass, continental polar, clear blue skies. If they looked straight up in City A, B, and C, they would see clear blue skies. There's no cloud formations over here. Okay, high and dry, high pressure, dry, clear blue sky. Kind of exciting and fun, right? So hope you enjoyed this screencast on cold fronts, and there will be others. Enjoy your day. Shoot for the pink suit mustache guy. Aspire to.